Hey guys, hope everybody's doing okay. What I want to do here is help you get started with some of these titration problems. So there's a titration homework problem set in your packet, and this is one of the first problems in that set. So I'll just help you get started with a few of these in the beginning here, and then you'll work through the rest on your own. If you have any questions, you can just let me know. So in this situation, we have a 14.3 milliliter amount of acetic acid, and it's neutralized with 32.4 milliliters of sodium hydroxide. What's the concentration of acetic acid? It says show the net ionic equation and assume acetic acid is not very soluble when writing the net ionic. So here's what we're going to do. We're going to start with acetic acid. So we have our formula for that. So it's HC2H3O2 plus sodium hydroxide. And that is going to be a double replacement reaction. We're going to create sodium acetate and water. All right. It says the net ionic equation. So it says assume acetic acid is not very soluble. So we're trying to find our spectator ions here. So the HC2H3O2 won't break up very much. The NaOH will, it's very soluble. The sodium acetate is very soluble, and water is a liquid, right? So if we're looking at ions that cancel out, sodium on each side, and it looks like I think that's it, okay? So none of the other ions are going to cancel here because acetic acid is going to remain mostly not dissociated. So let's rewrite that down here for our net ionic. We have the hydroxide ion left. We have our acetate ion left. And water. All right, so there you go. That's your net ionic equation to start this problem. So, anytime you're titrating something, moles of acid are equal to the moles of base at the equivalence point. And we could assume they titrated this appropriately. So we needed 32.4 milliliters of 1 molar sodium hydroxide to reach the equivalence point with the 14.3 milliliters of acetic acid. So if I find out my moles of base, that's going to be equal to the moles of acid I have in this problem. So let's figure it out. It's easy to do. Let's figure out the moles of NaOH. So the moles of NaOH are equal to, you have 1.5 molar solution, that's 1.5 moles per liter, and we needed 32.4 milliliters, that's 0.0324 liters. That gives us 0.049 moles of NaOH. 0.049 moles of NaOH was used to reach the equivalence point, which means we also have 0.049 moles of acid. So the moles of acetic acid is equal to 0.049 moles. Okay? I want to find the molarity of the acid. So the molarity of the acetic acid, I'm just abbreviating it because I don't feel like writing the whole thing out. The molarity is moles per liter, right? So that's 0.049 moles. And how many liters of acid did we have? We had 14.3 milliliters, so that is obviously 0.0143 liters. And you end up with a molarity of 3.4 molar acetic acid. Okay? A common mistake students make here is, you want to look at the moles of acid and moles of base and have them be equal. One of the issues here is with the volume of acid, it was only that 14.3 milliliters. It wasn't the 14.3 and the 32.4 combined, okay? It's just the 14.3 milliliters of acid was neutralized with the 32.4 milliliters of your base. So you figure out how many moles of base you had. That's equivalent to the moles of acid. And to find the molarity, it's moles of acid over liters of acid. That's the 14.3 milliliters of acid. All right, so just make sure we keep some of the small details under control, and you'll be okay. All right, so that's number one. Number two is very similar to that. It says you have 43.1 milliliters of calcium hydroxide is neutralized by adding 18.9 milliliters of 3 molar hydrochloric acid. What's the concentration of calcium hydroxide? So calcium hydroxide is our base. Hydrochloric acid is the acid neutralizing that. We always start with an equation because we need to know what our molar ratio is. Okay, here, 1 mole of acid reacted with 1 mole of base. Okay, we had that in our equation here. 1 mole of acetic acid, 1 mole of base. All right, that won't be the case here. So let's check it out. We have calcium hydroxide and hydrochloric acid, giving you calcium chloride and water. Okay, remember we need to balance all these. So if we look at how to balance this, we'll need a 2 here, 1 here, and a 2 there. Okay, so 1, 2, 1, 2. All right, so that's good. So now let's figure out what we have here. Okay, I can take my molarity and my volume of acid and figure out the moles, because I don't know the calcium hydroxide. So I need to find out my moles of calcium hydroxide and my volume of that. So to figure out the moles of calcium hydroxide, I have to go to something I do know, which is my information for the acid. So let's figure it out. I have 3 molar HCl, so that's 3.0 moles per liter. Okay, so that's just simple Chem 1 stuff here. Multiply that by the liters of acid, so 18.9 milliliters turns into 0.0189 liters. And that gives us 0.057 moles of acid. So the issue here is that you don't have 0.057 moles of base, because look, you need 2 moles of acid to neutralize 1 mole of base. All right, so simple stoichiometry like this, really easy to make a mistake here, but don't. Okay, do your stoichiometry like you know how, and it's really easy. I want to know how many moles of base. Right, I need to figure out my moles of base so I can find my molarity. So I have 0.057 moles of HCl. Cancel out moles of HCl and go to moles of calcium hydroxide. All right, look at your balanced equation. For every 1 mole of calcium hydroxide, you need 2 moles of acid. All right, so what we're ending up doing here is doing 0.057 divided by 2, which is going to give you 0.029 to proper sig figs moles of calcium hydroxide. All right, now we're basically done. Okay, so the molarity of calcium hydroxide is moles per liter, 0.029 moles over 43.1 milliliters, which is 0.0431. Gives you a molarity of 0.67 molar CaOH2. All right, so that takes care of it. So I did one on the previous slide where we had a 1-to-1 ratio, but always be aware of what that ratio is. So it's always good to write your equation out first. And we've got 2-to-1 ratio with calcium hydroxide to hydrochloric acid. All right, so then some students are like, do I divide by 2? Do I multiply by 2? Don't worry about it. Set up your stoichiometry and you'll never make that mistake. Okay, you'll automatically see that you got to cancel out moles of acid on the bottom, go to moles of base on top, and then you put your coefficients from the equation where they belong there. All right, now the next one starts a longer problem with titration curves. So we have propanoic acid, which the formula is there for you, and it's titrated with potassium hydroxide. So you want to start with a balanced chemical equation and net ionic equation, and then we want to figure out what kind of titration do we have here. Well, automatically we know that potassium hydroxide is a strong base. It's a group 1 hydroxide, and propanoic acid is a weak acid, all right, because it's not one of our 7 strong. All right, so you can easily do your acid and base reaction, and then it kind of scaffolds you and guides you through how you would solve a problem like this. And you could use the weak acid, strong base notes in your packet from the lesson we did in school or online, and you could go through and solve that. All right, so you're going to have C2H5 CO2H plus KOH yields. Now your propanate ion is going to be all of this except for the hydrogen. So you're going to make water, okay, HOH plus potassium propanoate, all right, from that ion, which not one we ever memorized, but it's okay. Okay. It really takes care of it. Okay, so you could cancel out some spectator ions. Your spectator is going to be potassium. Okay, and you could rewrite, just rewrite this underneath. C2H5 CO2H plus hydroxide yields water plus the propanoate ion. So it's good practice to do that. College Board asks you to write net ionics a lot. Okay, you guys can work through the rest, and if you have any questions, let me know. All right, thanks guys.